Domestic wastewater treatment using Flyash AA case study. Abstract wastewater treatment and disposal is a serious issue and need attention for protecting the environment. Over the recent years, fly ash has been experimented as an adsorbent for the wastewater treatment plants. The abundant availability, high carbon content and adsorption characteristics of fly ash lead to application in wastewater treatment methods. In this study, experiments were carried out using fly ash as adsorbent in domestic sewage water treatment. A filter media was prepared with pebbles, sand and fly ash with different thickness, characterized and used for the removal of impurities. The physio-chemical properties of wastewater before and after treatment were examined. The experimental results showed significant reduction in the values of BOD from 385 mg/L to 45 to 55 mg/L, COD from 680 mg/L to 110 to 150 mg/L, pH from 8.4 to 6.9 and TDS from 715 mg/L to 250 to 300 mg/L after treatment. Beneficial effects of fly ash utilization as adsorbent was observed for removing various impurities present in wastewater. Keywords: wastewater treatment and disposal. A adsorbent fly ash utilization. Introduction. Water is a vital component for all known forms of life to be able to survive. Water covers about 71% of Earth's surface, and is a valuable resource of the Earth. Earth is composed of approximately 30% of the world's fresh water is in liquid form and therefore potentially accessible for human use, such as drinking, to prepare food, washing clothes, and necessary functions, which water is a major component. Wastewater treatment is the process of converting wastewater, water that is no longer needed, into bilge water that can be discharged into the environment. The physio-chemical properties of wastewater before and after treatment were examined and reported in this study. Gray water is the water that goes down the drain from a laundry machine, bathroom sinks, shower, tub, and dishwasher. Gray water may have soaps and some minor amounts of biological, but nothing serious. Some consider the kitchen sink to be gray water, while others view it as black water because of the high organic potential, so keep that in mind. Gray water is not clean drinking water, and it is not black water, which is anything that has feces or sewage in it. Research by the Water Resources Research Center calculated that gray water accounts for 60 to 65% of home water use. By reducing the amount of water leaving our homes and reusing it inside our homes, we can significantly impact our total water consumption. This will more positively impact the environment and save money on your water bills. The objectives of this study are, to reduce the impurities from domestic wastewater by fly ash use as filter bed. To low-cost filter media is prepared, characterized, and used for the removal of impurities such as biochemical oxygen demand, BOD, chemical oxygen demand, COD, from wastewater. Generation of wastewater. Approximately 50 to 70% of the water used in your house results in gray water generation, and not even 5% of this is recycled in urban households. Here we see about the various sources of generation of gray water used in this project. Gray water from kitchen sinks. Kitchen sinks are the source of a fair amount of water, usually very high in organic matter, food, grease, etc. Kitchen sinks are not allowed under many gray water codes, but are allowed in some states of foreign countries. This water will clog many kinds of systems. To avoid clogging, we recommend using a branched drain system with mulch basins. Organic matter collects in the wood chips and decomposes. Since bathroom sinks don't typically generate much water, they can often combine flows with the shower water. Or, the sink water can be drained to a single large plant, or divided to irrigate 2 or 3 plants. Gray water from washing machines. Washing machines are typically the easiest source of gray water to reuse because gray water can be diverted without cutting into existing plumbing. Each machine has an internal pump that automatically pumps out the water. You can use that to your advantage to pump the gray water directly to your plants. Characteristics of domestic wastewater. Reuse of gray water. The reuse applications for gray water are watering gardens, fire hydrants, field irrigation, toilet flushing and cooling tower makeup. Gray water treatment and reuse is seldom in practice and not certainly to its potential values in considering the water sources. With growing demand for secondary uses like washing, gardening, groundwater recharging etc., gray water can be segregated using dual piping practice, and its treatment and reuse will bring the stress on water sources in all populated domestic locations. Generation of fly ash. Fly ash is produced by coal-fired electric and steam generating plants. Typically, coal is pulverized and blown with air into the boiler's combustion chamber, where it immediately ignites, generating heat and producing a molten mineral residue. Boiler tubes extract heat from the boiler, cooling the flue gas and causing the molten mineral residue to harden and form ash. Coarse ash particles, referred to as bottom ash or slag, fall to the bottom of the combustion chamber, while the lighter fine ash particles, termed fly ash, remain suspended in the flue gas. Prior to exhausting the flue gas, fly ash is removed by particulate emission control devices, such as electrostatic precipitators or filter fabric bag houses, see Figure 2.1. Literature review. Syed Farman Ali Shah et al., 2015, had conducted experiment in wastewater treatment using bed of coal fly ash for dyes and pigment industry. The treatment bed comprises of briquettes of coal fly ash coupled with commercial coagulant ferrous sulfate lime reduced cod, color, turbidity, and TSS of effluent remarkably. In coagulation treatment, coagulant FeSO4 lime influenced reduction of cod, color, turbidity, and TSS by 32%, 48%, 50%, and 51% respectively. The CFAB coupled with coagulant resulted in excessive removal of color, TSS, cod, and turbidity by 88%, 92%, 67%, and 89%. Dr. Pankaj Singh et al., 2014, studied domestic wastewater treatment using fly ash alone and in combined form. This study reports the use of fly ash alone and in combined state in different ratios with wood ash for the treatment of domestic laundry wastewater. Effect of various parameters such as combination ratio of fly ash and wood ash, contact time, adsorbent design, and particles of adsorbent have been studied. It is found that TSS reduced from 350 ppm to 15-20 ppm, BOD from 250 ppm to 10 to 20 ppm, and pH dropped from highly alkaline range in 8.5 to 9.5 range. Sandeep Thakur, et.al., 2013, reported to reduce surface and ground surface water use in all sectors of uses and to substitute fresh water with alternative resources. The author suggested that gray water recycling is the variable option that can be very useful in the water arid areas. Akpong et. al., 2012, reported the design and construction of a filter for gray water reuse for irrigation of not less than 100 household. Laboratory tests were conducted on these samples and they revealed the presence of BOD, TSS, nitrate pH, coliform etc., whose values were compared with that of the parameters for standard irrigation water. The author suggested that the efficiency of the slow sand filter in the reduction and all the parameters were high due to their tangible nature, which enables them to succumb surface forces of the filter media. Basaheb L. Pongarkar, et.al., 2010, investigated the economical performance of the plant for treatment of bathrooms, basins, and laundries. Gray water showed in terms of deduction competency of water pollutants such as cod, 83%, TDS, 70%, TSS, 83%, total hardness, 50%, oil and grease, 97%, anions, 46%, and captions, 49%. The author suggested that the technology could be a good alternative to treat gray water in residential rural area. Fly ash. Materials and methodology. Fly ash is collected from Niveli Lignite Corporation, NLC. This material is easily available in all thermal power stations. For preparing filter bed with fly ash, it can be sieved through 90 micron sieve. Fig shows 3.1 are the sieved material of fly ash. Effluent. Wastewater was collected from home in kitchen sinks and washing clothes. The sample were collected periodically, thrice in a week for a month for this study. It has high concentration of cod, TSS, TDS, pH, and the dissolved oxygen level, DO, would be very low. Sand. River sand was used in this study to prepare the sand bed in the filtration tank. The river sand was sieved through 2.36 mm sieve before application. Pebbles. Pebbles are generally considered larger than granules and smaller than cobbles. In this study, small size, maximum 10 mm, pebble were used in the filter media. The pebbles were washed with distilled water and dried. Experimental method. Treatment of gray water carried out in the laboratory using a reactor makeup of 2 containers of 2-liter capacities placed one above the other with a filter mesh of less than 0.0001 micron size. Fly ash, sand, pebbles are filled in the filter media for treating the gray water. Preparation of adsorbent. The fly ash was conditioned by washed through distilled water to remove the unstable or water-soluble particles present in it. After washing, the fly ash was allowed to dry in room temperature followed by vacuum desiccator for a day. After this process, the dried fly ash was sieved through 900 AAM sieve and used in the filter bed. Filtration process. Initially, the filter bed cleaned well. Fly ash is sieved in micrometer sieve and taken up. The pebbles which are lying in the bottom layer should be wasted with distilled water and dried in the sunlight for few minutes. The river sand taken is sieved in 2.45 micrometer. The untreated effluent should be tested to get initial readings of cod, DO, TSS, TDS and pH. First, the bed of 40 mm is made and the laying bottom layer with pebbles, then layer of fly ash and top layer is of sand. Each layer has 40 mm thick. Then the effluent is poured into the bed. After 24 HRS left, it has been tested. The tests are determination of cod, DO, TSS, TDS, and pH. The same procedure is followed for the consecutive layers, 30 mm, 20 mm, 10 mm. Finally, the effective thickness in which the fly ash will give better results should be determined. The following tests were conducted on the sample to know the physical and chemical properties of the gray water. Chemical oxygen demand. The 20 ml of wastewater is taken in 500 ml round bottom end flask. Add H2SO4 and few glass beads followed by 20 ml of 0.1 N potassium dichromate solution. Add slowly 10 ml of CONCH2SO4 plus Ag2SO4 reagent and mix thoroughly. The flask is fitted with a reflux water condenser and the mixture is refluxed for 2 hours. The mixture is transferred to a conical flask, diluted to 100 ml and 5 drops of ferrite indicator is added. The non-reactive dichromate is titrated against standard ferrous ammonium sulfate taken in the burette till the color changes to the blue-green to red-brown. Total suspended solids. Take the empty crucibles and clean it thoroughly, make it perfectly dry. Take the weight of the empty crucible, say W1, W2. Take sample 1 and 2, 10 ml without filtered in crucible W1 and filter the sample with filter paper number 44 respectively in the crucible W2. Dry the crucible in the muffle furnace at the temperature of 105 AA degree C till the crucible gets complete dry and cool. Weight the crucible and record the crucible weight as W3 and W4 and calculated. Total dissolved solids. Take the empty crucibles and clean it thoroughly, make it perfectly dry. Take the weight of the empty crucible, say W1, W2. Take sample 1 and 2 10 ml without filtered in crucible W1 and filter the sample with filter paper No. 0.44 respectively in the crucible W2. Dry the crucible in the muffle furnace at the temperature of 105 AA degree C till the crucible gets complete dry and cool. Weight the crucible and record the crucible weight as W3 and W4 and calculated. pH. Wash the combined electrode of PL meter with distilled water and clean the same with distilled water. Dip the combined electrode in the buffer solution of pH value 4.02. Adjust the temperature by the adjustment knob to an ambient, room, temperature. If the instrument shows the reading as 4.02, then it is in order. If not, adjust the reading to 4.02 by calibration adjustment knob. Wash the electrode of pH meter with distilled water and clean the same with distilled water and dip it to the buffer solution of pH value 9.12. Note the reading. If the instrument shows the reading as 9.12, then it is in order, otherwise uses the calibration adjustment knob and bring the reading to 9.12. Repeat the above procedure until the meter shows reading as 4.02 when electrode is dipped in buffer solution of pH 4.02 and shows reading as 9.12 when electrode is dipped in buffer solution of pH value 9.12. 6. Now the instrument is calibrated. Dip the electrode into the sample solution, stir the solution and wait up to 1 minute for steady reading. Directly record the reading from the meter without doing any adjustments. Results and discussion. The experimental results were presented in Table 4. Comparison among the pretreated and treated domestic wastewater were presented in the following paragraph. Table 4: Physio-chemical properties of treated and pre-treated wastewater. Removal of cod from the wastewater. Chemical oxygen demand is a measurement of the oxygen required to oxidize soluble and particulate organic matter in water. Before treatment, the level of cod is above than permissible limit 300 mg/L. After treatment, the COD value decreased to 80 mg/L in the thickness of 10 mm. It is clear that the effective thickness is 10 to 20 mm as shown in Fig. 8. Removal of TDS from the wastewater. The term total dissolved solid refers to materials that are completely dissolved in water. These solids are filterable in nature. Estimation of total dissolved solids is useful to determine whether water is suitable for drinking purpose, agriculture, and industrial purpose. Before treatment, the level of TDS is above than permissible limit 2000 mg/L. After treatment, the TDS value decreased to a 700 mg/L in the thickness of 10 mm. It is clear that the effective thickness is 10 to 20 mm as shown in Fig. 9. Removal of TSS from the wastewater. The term total suspended solids refers to materials which are not dissolved in water and are non-filterable in nature. It is defined as residue upon evaporation of non-filterable sample on a filter paper. In industries, use of water with high amount of dissolved solids may lead to scaling in boilers, corrosion, and degraded quality of product. Before treatment, the level of TSS is above than permissible limit 3500 mg/L. After treatment, the TSS value decreased to 80 mg/L in the thickness of 10 mm. It is clear that the effective thickness is 10 to 20 mm as shown in Fig. 11. Reduction of pH content of the sample. Reduction of pH level in the consecutive layers as shown in Fig. 12. Conclusion. Coal fly ash bed is an inexpensive and effective for removal of cod, TSS, TDS, and pH reduction due to its high porosity and adsorption capacity. Fly ash is available in abundance at coal-fed electric power plants, can be effectively used for treatment of wastewater. When fly ash is used as filter bed of 10 mm, 20 mm, 30 mm, and 40 mm thickness, the parameter value is reduced to great extent from initial value in 10 to 20 mm thick. It is concluded that the fly ash is better option for the treatment of wastewater treatment. The obtained result values are within the permissible limits. Environmental pollution issues can also be minimized by using coal fly ash bed in wastewater treatment.